Okay, I think we are live. So yeah, I think everything is sorted. So yeah, hello and welcome to this session. स्वागत है आज आप सभी का आज के इस सेशन में. Yeah, so I can, because everything is fine, so that we can start the session now. Yes. Can someone please confirm in the chat box if my voice and video is perfectly fine? Okay. I think we can start now. Everything seems to be perfect. Yeah, okay. Yes, so स्वागत है आप सभी का आज के सेशन में. So yeah, this is regarding IIM Bangalore's UG admission test. So I hope you are following us in this series because ये पहला सेशन नहीं है. We have already conducted a lot of sessions for IIM Bangalore's UG admission test. So आप just इस चैनल पे विजिट कर सकते हो. अगर आप फर्स्ट टाइम हमारे चैनल पे विजिट कर रहे हो तो काफ़ी सारी वीडियोस ऑलरेडी आपको मिल जाएंगी चैनल पे. हमने काफ़ी सारे सेशंस ऑलरेडी लिए हुए हैं. So you can just visit our channel. Today's session is on number system. So all the sessions are there on this particular channel. So I would recommend if you are preparing for IIM Bangalore UG admission test or if you are preparing for IPMAT also, you can just visit our channel. You will be finding all the sessions there. This is a free video series that is being conducted by Team Cracku. Okay, these sessions will be very beneficial for you if you are preparing for IIM Bangalore's UG admission test. Okay, so I think we can now start with the session for today. Yeah, so before we begin, I have a few updates for you. This is the very first update that is regarding WhatsApp channel. So okay, so you can join us on our WhatsApp channel for free preparation resources as well as important updates. So कोई भी preparation resource अगर हमें आपके साथ कोई share करना है, so we will be sharing those free preparation resources with you on the WhatsApp, as well as if there are any important updates, those also we will be sharing in that particular WhatsApp group. So you can find the link of that WhatsApp group in the description box of this video. So I would recommend कि आप उस ग्रुप को ज्वाइन करो बिकॉज काफ़ी स्टूडेंट्स ने वो ग्रुप ज्वाइन किया है. तो अगर कोई अदर स्टूडेंट है जो और वो भी इस एग्जाम के लिए प्रिपेयर कर रहा है, सो यू कैन इंटरेक्ट विद दोज स्टूडेंट्स सो दैट you have a better environment, right? Whenever you want to discuss anything, you can discuss with those students who are also preparing for this exam. Okay, so this was about the WhatsApp channel. Okay, and this is regarding the session. Like I told you, this is not the first session, and these sessions are already being conducted on our channel, that is functions and mixtures, allegations and triangle. Today, that is 13th of November, आज नंबर सिस्टम का सेशन है, and there will be one more session on नंबर सिस्टम. आज मैं कुछ बेसिक्स स्टार्टिंग कवर करूँगा. उसके बाद जो सेकंड पार्ट है उसमें जो रिमेनिंग पार्ट रह जाएगा नंबर सिस्टम का वो कवर किया जाएगा. ओके, सो दिस इज पार्ट 1 बेसिकली. आफ्टर दैट टुमारो यू कैन सी द सेशन इज ऑन सर्कल्स, then permutation and combination, then of course there's a one webinar. So this webinar is being conducted by IIM Bangalore. So if you have any doubts regarding how to prepare, what is the syllabus of this exam, so you can just join this webinar. अगर आपको इसकी डिटेल्स चाहिए तो एक शॉर्ट वीडियो हैज़ बीन अपलोडेड ऑन दिस चैनल. सो बाय वाचिंग दिस वीडियो, दैट शॉर्ट वीडियो, आपको पता चलेगा कि आपको उस वेबिनार को कैसे ज्वाइन करना है. सो अगर आपके पास कोई डाउट है कि कैसे प्रिपेयर करना है, क्या सिलेबस है, कैसे क्या आएगा, सो यू कैन ज्वाइन दिस वेबिनार and you can directly talk to the officials. Okay, and of course उसके बाद एक quadrilaterals का session है, that is on 17th of November. And this is the last update, that is we are providing 5 free mock tests. You can just visit our website, that is cracku.in/IIM Bangalore UG mock test. You can visit this and you can find 5 free mock tests on the platform. You can give those. You can just click on the free mock because this is a screenshot, so I won't be able to click on this. So you can just visit here. You need to just register, and these mocks are free and are prepared by experts. So of course this will be also very beneficial for you if you are giving this IIM Bangalore's UG admission test. Okay, so these were the updates. Okay. Yeah, so let's start with today's session, that is the basics of number system. So first, let's try to understand the classification of numbers. I think everything is sorted. Let's see. Okay. Yeah, so let's start with the topic, that is classification of numbers. So जो दो ब्रॉड कैटेगरीज हैं जिसके अंडर हम नंबर्स को डिवाइड कर सकते हैं, दैट आर रियल नंबर्स एंड imaginary numbers. So what are real numbers? Any number which you can represent on the number line will be real number. For example, let's say this is the number line. Okay, this is the origin, that is 0. So if I say any number, let's say 2, 5, whatever number I say, you will be able to represent on this number line. That if I say 2, then this is 1, let's say this is 2, so you are able to identify the number on the number line. If I say, let's say number 5, or maybe negative integers also, negative numbers also. If I say -3, this is -3, so you will be able to represent this on the number line. Okay, and also if the number is in fraction, for example it is 11/5, so first आपको उसकी value calculate करनी पड़ेगी, that is 11/5. so I think आप basic calculation कर सकते हो, that 11 into 2 is 10, then taking the decimal it is 2, so essentially it is 2.2. so next number 3 होगा, so 2.2 will lie somewhere in between, right? So but you are able to identify that this number, this particular number lies somewhere here. So you are able to represent these numbers on the number line. So any number that you will be able to represent on the number line are known as real numbers. So now talking about imaginary numbers. Yeah. So let's talk about imaginary numbers also. For example, if I ask you to calculate the value of x square, that is equal to -9. So if it was 9, let's say x square was equal to 9, then you could have simply solved it and said that okay, the value of x can be 3 or the value of x can be -3 also, because 3 का square भी 9 होगा, -3 का square भी 9 होगा, right? So essentially आप value निकाल पा रहे हो उसकी, right? But here you can't find the value because x square is equal to -9. So what you can do is take -1 and you can write it as 9, taking the square root, it will give us root -1 into 3 or maybe -3. But what is important is that you don't know the value of this, so you won't be able to represent this on the number line, right? Even though we denote it by I, that is iota, so it will be 3i or -3i, but essentially you won't be able to represent these numbers on the number line. So these are imaginary numbers. Okay, so essentially these are the two broad categories, that are real numbers and imaginary numbers. So now all the other things that आप देख रहे हो, यहाँ पे natural number है, whole number है, so all these come under real numbers itself. So let's try to understand about those numbers also. Okay, let's first try to understand what is integers. Like I told you in the last step, whatever you can represent on the number line, as well as there is no decimal in that part, in that number. For example, let's say I take a number 2, right? So it is an integer, it is free from decimal. If I say the number, if the number is, let's say number is 5.5, so this is not an integer because it is represented by decimal. Okay, so any number which is free from decimals is termed as integers. It can be positive also, it can be negative also. So all these numbers, let's say I write 1 here, 2 here, maybe 5 here, these all numbers are integers free from decimals. It can be negative also, let's say -1 or -2, maybe -6 and so on. So these are integers which are free from decimals. Okay, so continuing from integers, let's try to understand what is natural numbers. So all those integers which are positive are termed as natural numbers. If we try to understand from this number line, so all these numbers starting from 1 to positive infinity, these numbers are natural numbers. Okay, also for the whole numbers we just need to include 0 also. Okay, so for the natural numbers it is starting from 1, 2 and so on, right? All these numbers are natural numbers. And for whole numbers we take non-negative integers, that is just need to exclude this part. We need to exclude this part and all these numbers come under whole numbers. Okay, so whole numbers will be all these numbers starting from 0 and so on. So these numbers are whole numbers. Okay, this was about whole numbers. Let's try to understand some details about prime numbers and coprime numbers. Okay, so any number which is divisible by itself and 1, only two factors are there of the number, then those numbers are termed as prime numbers. For example, let's say I give you a number that is 6, for example, let's say 6. So 6 is divisible by 1 because every number is divisible by 1. So apart from 1, 6 is divisible by 2 also, right? It is divisible by 3 also, and it is divisible by 6 also. So because 6 has more factors than itself and 1, so it is not a prime number. So essentially, prime number means any number which has factors only itself and 1. Like if I write, let's say 5, so 5 is divisible by 1, it is not divisible by 2, 3, 4, it is divisible by only 5, right? So it is divisible by only itself and 1, so it is a prime number. Okay, so likewise we can write 7 also, or 11 also, and 13 and so on. The smallest prime number is 2 because 2 is divisible by 1 and itself, right? 2. So smallest prime number is 2, and also 2 is the only even prime number because after 2 any even number is not a prime. Okay, because 2 is divisible by only 1 as well as 2. So one more pattern that you need to identify for prime numbers is that it follows a certain pattern. For example, for any prime number, you can represent it in the form of 6k plus minus 1. Okay, but every number of this form is not a prime number, but any prime number will follow this pattern. What does this essentially mean? Okay, let's try to understand that here. Okay, so let's say आपको 40 से 60 के बीच में प्राइम नंबर्स कैलकुलेट करने हैं. Okay, let's say between 40 and 60 you need to see how many prime numbers are there. So like I told you, जो भी प्राइम नंबर्स हैं वो 6k plus minus 1 के फॉर्म को फॉलो करेगा. Okay, so between these numbers, the first number that will be of the form 6k plus or minus 1 will be 6 into 7 plus minus 1, that is 42, minus 1, that is 41, then 43. The next multiple will be 6 into 8 plus minus 1, that is 48 plus minus 1, that is 47 and 49. Same way, the next multiple will be 54. So the two numbers will be 53 and 55. If we will taking the next multiple, which is 60 essentially, then plus minus 1 will give us 59 and 61. So because we needed between 40 to 60, so we can exclude 61. Okay, so say 41 is prime number because it is not divisible by 1, 2 or maybe any number apart from itself and 1. Same for 43 also, it is not divisible by any number. Same for 47 also, it is not divisible. Okay, but 49 is divisible by 7. Okay, 55 is divisible by 5 and 11. 59 is also not divisible by any number. 53 is not divisible by 3, by 5 or 7 or 11. So it is also a prime number. So what I am trying to essentially tell you is that by using this pattern, you will be able to identify the prime numbers. So you are not missing out on any number. मतलब आपने जब इस पैटर्न के नंबर्स को लिख लिया है तो इसके बीच में और कोई प्राइम नंबर नहीं होगा. प्राइम नंबर्स या तो ये होंगे या तो इनमें से भी हो सकता है कोई प्राइम नंबर ना हो, बट इसके अलावा कोई नंबर नहीं होगा. सो इट विल जस्ट ईज योर कैलकुलेशंस. ओके, सो एनी नंबर, मतलब प्राइम नंबर्स विल ऑलवेज फॉलो दिस फॉर्म, but all the numbers of this form are not prime numbers. So you can see here that 49 is not a prime number, 55 is not a prime number. Okay, so by doing this you can just ease your calculation. So this was all about prime numbers. So what are co-prime numbers? Okay, so if I have any two numbers, or maybe three numbers also, let's say I have two numbers that are 3 and maybe let's say I take 5. So these are two numbers which don't have any common multiple that between them. So कोई ऐसा नंबर नहीं है जो 3 को भी काटे और 5 को भी काटे, right? Apart from 1, if there is any number, then these numbers won't be co-prime, right? So these two numbers are co-prime because there is no common multiple of these two numbers. But if say, let's say I have taken two numbers as 6 and 10, okay, so I have taken two numbers as 6 and 10. So here you can notice that 6 is divisible by 2, 10 is also divisible by 2. So apart from 1, we have one multiple, we have one number which divides both of the numbers. So these two numbers are not co-prime. So if the two numbers don't have any common multiple between them, then those two numbers will be co-prime. Same can happen for three numbers also. It is not that कि खाली दो numbers पे co-prime होगा. अगर आपके पास तीन numbers हैं, for example, let's say you have 3, you have 9, you have let's say 11. Okay, so here also if there is no common multiple between them, so these numbers are co-prime. Okay. I think that was it about co-prime. If you have any doubts, you can just put it in the chat box. And one more thing is that the numbers in itself need not to be prime. Like some students confuse that, okay, only prime numbers can form co-prime. If I give you two numbers, let's say 6 and 11, then 6 is not a prime number, but 6 and 11 are co-prime. Okay, so the numbers in itself need not to be prime number, but the common multiple between that particular number and other number should be 1. Only 1 should be the common multiple. Otherwise, if there are no common multiples, then these two numbers will be co-prime. Okay, so I think this was also an important point that you should not miss. I'll tell you about rational numbers and irrational numbers in the next slide. Meanwhile, if you have any doubts, you can put it in the chat box. Okay, I think you don't have any doubts. So moving ahead. Okay. Okay, so now we are talking about the decimal numbers. So like I told you, अगर किसी भी नंबर में डेसिमल है तो वो इंटीजर नहीं होगा. So right now we are studying about the decimal numbers जिसमें कुछ मतलब जो इंटीजर्स नहीं है. For example, if I take let's say any number 3.4271, right? So this is a number which is terminating. By terminating it means after decimal ये 1 पे end हो गया, right? इसके बाद ये continue नहीं हो रहा. We have terminated the decimal. So this is first part of this particular slide, that this number is terminating. So we can represent this number in the form of p by q. That is, we can just remove the decimal, that we can remove the decimal from here. So this will become as 4 times 0. Okay, yeah, so we can represent this number in the form of p by q. So this is about terminating decimal. You can take any number. For example, let's say you took 5.73. So you can just write it this number as 573 divided by 100, or maybe let's say 4.2931, any number you can take. So you can just remove this decimal and you can represent this in the form of p by q. If there is some common multiple in the numerator and denominator, we can definitely cancel it. But the point is that these numbers are terminating, so we can represent them in the form of p by q. Second thing is that you will be finding some numbers which are non-terminating but recurring. Let's try to understand with the help of an example. Yeah, okay. So number that is non-terminating but recurring. By non-terminating I means it will not end. For example, in the last number that I have taken, it was ending at 1, right? But here, let's say there is a fraction that is 10 by 3. So when you will be solving this fraction, I think I should write a bit larger so that it should be clearly visible, right? So if I had taken 10 by 3, so when you will be solving it, so what you will get is 10 into 3, 3 into 3, that is 9. So 1 will be remainder. You will take a decimal, then again 3, that is 9, then again because of decimal is 0, and so on, right? So it means this will be 1. Right, so it is not terminating, right? You will be getting the answer as 3.333 and so on. So it is non-terminating but recurring. By recurring, it means that it is repeating. So even though it is non-terminating, but it is like the same number is being repeated. Okay, so this number also we can represent in the form of p by q. You have already seen it. So how do we do this? Okay, so if we have a number, let's say in the last case it was 10 by 3. So let's say some other example if we take, that is 0.333. This is a number. So when any number is repeating, so we can just represent it with the form of bar. For example, we can write this number as 0.3 bar. So by this bar, it means that 3 is getting repeated infinitely. Okay, so how do we convert it in the form of p by q? Let's say x is equal to 0.3 bar. Now we can just multiply this number by 10. I think you must have done this in your class 9th or 10th. So essentially it is 3.333 and so on. So by multiplying it by 10 on both sides, this will come out to be 3.333 and so on. So now from this equation you can subtract the earlier one equation. So what you will get here is that 10x minus x. So on the right hand side it will be 3, and all the remaining part will be cancelled out after the decimal. Okay, so essentially 9x is equal to 3. So x will come out to be 1 by 3. So we are able to represent this number in the form of p by q. That is, by p by q I mean there will be some integer in the numerator as well as there will be some integer in the denominator also. So this is the p by q form. So we can represent any number which is of the form non-terminating but recurring in the form of p by q. There will be some more numbers that is non-terminating and non-recurring. For example, okay, let's say I took a number that is 0.213723591 and so on, right? So it is non-terminating because वो end नहीं हो रहा, कोई भी number अभी रुका नहीं है, चलता जा रहा है, series चलती जा रही है, and also it is non-repeating because same number is not getting repeated. So it is non-terminating as well as non-repeating. So we cannot represent it in the form of p by q, right? So this was about non-terminating and non-recurring. So if I take any number, for example, if I have to calculate a root of 2 or maybe root of 5, so you will see that these numbers are non-terminating as well as non-recurring because the value of root 5 will be somewhere close to 2.23, something like that, but it will be non-terminating as well as non-recurring. Same for the case of root 2. So these numbers are non-terminating as well as non-recurring, and you won't be able to represent those numbers in the form of p by q. Okay, so this was about non-terminating as well as non-recurring. Let's see if you have any doubt. Let me take a sip of water. So if you have any doubt, you can just put in the chat box. Okay. Okay, I think everything is sorted. So like I told you, the rational numbers and irrational numbers was left. Okay. So any number that you can represent in the form of p by q, like I told you in the earlier slide, the next slide here. So whatever number that you can represent in the form of p by q is known as rational number. And any number that of course you cannot represent any number, if there is a number that you are not able to represent in the form of p by q, then it will be irrational numbers. Okay, so what are rational numbers? Let's say if I represent any number that is 7.41 and so on, so you will be able to represent it in the form of p by q. That is, there is some integer in the numerator as well as there is some integer in the denominator also. Okay, and also if there is some integers also, then integers are also termed as rational. Because let's say I take an integer 5, then let's say this x is equal to 5, so I can just take 1 in the denominator. So I have been able to represent this number in the form of p by q. So essentially all the integers are also rational numbers. So any number you are able, if you are able to represent the number in the form of p by q, then it will be rational numbers. If you are not able to represent in the form of p by q, it will be irrational numbers. So this was about the basic things about natural numbers, whole numbers or integers, rational numbers, irrational numbers, prime numbers as well as co-prime numbers. Okay, moving ahead, I have already told you about these things. Okay, so I think this is an important slide now. So this is about factors and multiples. How do you calculate the factors of a number? Even though I have taken one example, that is factors of 12 are 1, 2, 3, 4, 6 as well as 12. Let's try to take an example for this. Let's say I take a number 30. Okay, so I have taken, let's say number that I have taken is 30. So what are the factors of this number? So it is divisible by 1, it is divisible by 2 also, then 3, then 5 also, 5 into 6 that is 30, then 6, then 10, of course, then 30. Okay, so these are the factors of this number. So all those numbers which essentially divide this number without leaving any remainder, these numbers are factors. Okay, multiples is nothing, just if I have a number 30, so if I am multiplying it by, let's say, any integer, maybe 2, or maybe let's say I multiply it by 4 or maybe 5, so I will get here 60. If I multiply it by 4, then I will get 120. If I multiply by 5, then I will be getting 150. So these are the multiples. But I think this is more important to learn here is that the factors of a number. But one more thing here is that this was a smaller number that I took, it was 30. So I was able to just do the manual calculation. But what will we do then when the number will be a lot larger? For example, if I have to calculate the factors of 1000 or maybe 27,000, 50,000 or so on. So I won't be writing it like this way, right? So what we can do is just we can do prime factorization. See, for 30 also, if we do the prime factorization, I think you must have done this also in your school time, that 2 into 15, then 3 into 5, then 5 into 1. So this is the basic that we do during our school days. So we can write 30 in terms of prime factorization, that is 2 into 3 into 5, of course raised to power 1, right? So to get the value of total number of factors, what we will be doing is that total number of factors will be equal to, I should remove this, just add 1 to the power. For example, let's say if this is of the form a raised to the power p, b raised to the power q, c raised to the power r. So if we need to calculate the total number of factors, what we can do here is that we need to just add 1 to the powers. Okay, so taking the example here, the factors for 30 were 1, 2, 3, 5, 6, 10 and 30. So these were the factors of 30. So with the help of this formula, the value of p here is 1. So that is 1 plus 1, that is 2. Value of q also it is 1, and value of r also it is 1. So we will just multiply these numbers. So this will come out to be 8. So you can check there is that 1, 2, 3, 4, 5, 6, 7. I think I have missed one factor. 15 also, yes, okay. 15 also will come now. So here you can check that the factors are 1, 2, 3, 4, 5, 6, 7, 8, and essentially you are able to calculate with the help of this formula. Because अगर कोई बड़ा number होगा, so you won't be able to do this manually, right? So why we are just adding 1 to the numbers? Because logic समझना भी important है. Just learning the formulas won't help, right? So let's try to see why we are essentially adding 1 to this value. We have this value, right? So 30 is equal to 2 raised to the power 1 into 3 raised to the power 1 into 5 raised to the power 1. So what we can write here is that in 2 raised to the power 1, we have 2 raised to the power 0 as well as 2 raised to the power 1. Okay, so it is 2 raised to the power 0 as well as 2 raised to the power 1. Now this second term also, it has 3 raised to the power 0 as well as 3 raised to the power 1. For the third term also we have 5 raised to power 0 and 5 raised to power 1. Okay, so we have these values. So now what we will do to get to these factors, we have to take one value from each of the bracket. Let's say I took from this bracket 2 raised to the power 0 multiplied by 3 raised to the power 0. Okay, that is 3 raised to the power 0, and any number raised to the power 0 gives us 1. Okay, so this will be 1 into 1, that is 1. So we have got this. Okay, let's try to take some more values. Let's say I took 2 raised to the power 0 from here, and I took 3 raised to the power 1 from here. So this will give me 1 into 3, that is 3. So we have got this factor also. I think I can write here, it will be visible. Okay, so let's take 2 raised to the power 1 from here and 5 raised to the power 1 from there also. Then it will come as 2 into 5, that is 10. So likewise you can check that by taking the values from these, you will be able to figure out all the factors. So this essentially what we are doing is that we are taking one value from this bracket, we are taking one value from this bracket, and we are taking one value from this bracket. Okay, so I think I missed it here, right? So from here you will have to take one value from this bracket also, that is 5 raised to the power 0, that is 1 into 1 into 1, that is 1. In this case also, if I take 5 raised to the power 0 from here, it will come out to be 6 only. But let's say for the third case, if I take 2 raised to the power 1, 3 raised to the power, let's say I took 0, and 5 raised to the power 1 I took, then it will come out to be 2 into 1 into 5, that is 2 into 5, that is 10. Okay, so what we are doing is that we are taking one value from the each bracket. So we have two values from this bracket, we have two values from this bracket, we have two values from this bracket. So essentially we are taking one value from the 2, again we are taking one value from the 2, and again we are taking one value from the third bracket also. So essentially we have come to the formula, that is we are adding 1 because of this 0 power, because of which we are adding 1 to the each value of power. So I hope this must be clear because understanding the formula is also important. So that's why I told you that you should be aware that why we are adding 1 to the powers. So I hope this must be clear. By taking one value from each of the bracket, you will be able to identify that you are getting, let's say, 2 also, 5 also. Just by taking the values from this bracket, you will be able to figure out all the factors. I think this should be pretty much clear. If you have any doubts, you can just put it in the chat box. And this was about factors. Let's move ahead. First look at if you have any doubts. Okay, I think we can move ahead. There are no doubts. Okay, moving ahead. Yeah, so the number of factors, I have already told you about how to calculate total number of factors. Let's get to a previous example. We took n is equal to 30. So the factors of 30 were 1, 2, 3, 5, 6, 10, 15 and 30. So these were the factors. So we were able to figure out the formula for total number of factors. Now let's look at how to calculate even number of factors. So like the formula I told you in the previous slide, that the factors will be p plus 1, q plus 1 and r plus 1, right? Like I represented 30 as 2 into 3 into 5. So PQR is basically this one, the power. Okay, so essentially what you need to do is, now you need to calculate the even number of factors. So what will you do for the even number of factors? You just don't need to add 1 to this particular, so this particular term. For example, if you need to calculate the even number of factors, so just don't add 1 to this first term and write the remaining terms as it is. So what you will do is p into q plus 1 into r plus 1. Okay, so what we will get here is p is same as 1, q will be added 1, then it will be 1 plus 1, that is 2, and for 5 also 1 plus 1 will be 2, so it will be 4. Okay, and if you want to calculate odd number of factors, then don't include this particular term at all, because we don't want even numbers, we just need odd number of factors. So for odd number of factors, what you can do is just ignore the first term, just you need to focus on the remaining terms. Okay, so it will come out to be q plus 1 and r plus 1, that is 2 into 2, that is 4, and of course the total number of factors, that are 8, will be always be equal to even number of factors plus odd number of factors. So you may ask that why we are not adding 1 to this term and why we are neglecting the first term. I need to explain that also. Let's try to understand this. Like I told you in the last slide, for the formula that I explained you for total number of factors, let's try to get back to that formula. The 30 is equal to, or let's say the number was 30, the factors were, that I wrote when I was explaining that, it was p plus 1, q plus 1 and r plus 1, right? And the factors of 30 are 2 into 3 into 5. So what we did was, because in the power of 1 we have 2 raised to the power 3 0 also, 2 raised to the power 1 also, we have 3 raised to the power 0 also, 3 raised to the power 1 also, we have 5 raised to the power 0 as well as 5 raised to the power 1. So if we want to find the even number of factors, so if we will, let's say we include 2 raised to the power 0 here, so one term that we will get here will be, okay, so if we want to calculate even number of factors, so we can't include 2 raised to the power 0, because we need at least one term that is of the order, that is a multiple of 2. So if we will include 2 here, so what we will get here is that 2 raised to the power 0 multiplied by, let's say we take any value from here, it will be odd number, right? If we take, let's say 3 raised to the power 1, or maybe 5 raised to the power 1, or 2 raised to the power 0 into 3 raised to the power 0 and 5 raised to the power 1. So essentially, because we don't have any value of 2 raised to the power, so these numbers will come out to be odd, and we need even number of factors. So because of that, we won't add 1 to this value, so that we get at least 1 power of 2. And since we are taking one value from each of the brackets, so essentially we will be having 2 raised to the power 1, and with whatever number we multiply 2 raised to the power 1, we get even number, because even number multiplied with any number, we will be getting even number only. So that is why we are not adding 1 to this number. So because of this reason, I think understanding the logic is also important. खाली formula याद करके, see, you will be able to solve the easy level questions, or let's say some direct level questions. But जब तक आपके फंडे नहीं क्लियर होंगे कि हाँ ये फॉर्मूला कहाँ से आया, सो आपको थोड़ा सा दिक्कत होगी जब थोड़े से एडवांस लेवल क्वेश्चंस आप करोगे. Okay, so I think this should be clear, because of this particular reason we are not adding 1 to this for calculating even number of factors. And I think it must be pretty much clear for odd number of factors, because we need only odd value, so we are just eliminating this value, that is the even number of factors, that is the even terms. We are just neglecting this, and we are just calculating this, because we need only odd factors, so we won't be considering 2 raised to the power 0 or 2 raised to the power 1. We will just focus on 3 raised to the power 0 and 3 raised to the power 1, as well as 5 raised to the power 0 as well as 5 raised to the power 1. I think this should be also pretty much clear. So I think you must be able to understand why we are doing how we are getting to the formula, right? So I think this must be pretty much clear why we are not adding 1 here, and why we are just eliminating all the terms that are in the power of 2. So this was about total number of factors, as well as even number of factors and odd number of factors. If you have any doubts, it is this time that you should ask now. Okay, Udit, so we can do this for more than 3 prime factors also. If you have any doubt, you can just put a number in the chat box. I will be happy to take that number. You can just put whatever number you have and whatever doubt you have. If you want to calculate any total number of factors or even number of factors, you can put in the, let's say कोई नंबर है आपके दिमाग में कि इस नंबर के बताओ कितने, कैसे कैलकुलेट करेंगे टोटल नंबर ऑफ फैक्टर्स, आप डाल सकते हो, उस पर भी एप्लीकेबल होगा. ओके, I think this was it about total number of factors and even number of factors. सी आई थिंक आप यहाँ पे पूछ रहे हो, अब यहाँ पे अगर आपको लग रहा है कि 4 फैक्टर्स हैं, सो यू कैन जस्ट add let's say some new variable s, so you can write it as s plus 1, or you can continue it whatever number of factors are there. Let's say factors are 2 3 5 7 11, so you can add one more variable there, but generally उतना ज़्यादा पूछता नहीं है, वो ज़्यादा कैलकुलेटिव हो जाएगा, right? So generally it is just with the 3 factors, but yes, because this formula will work for any number of prime factors that you have. I think this should clear your doubt, but still if you have any doubt, you can put it in the chat box. Yeah, so let's come to sum of factors and product of factors. Taking the same example again, that is, let's say the number is the number is 30. So we got the factors as, let's write again for the better clarity. Okay, so essentially what we had in the prime factorization, we wrote it as, that is prime factorization. So into 3 raised to the power 1 into 5 raised to the power 1. So this is essentially what we have already covered in the last slides. Now we need to find the sum and product of factors. So how we can do it? Because I have explained you how the formula comes, so it will be better now for you to understand those things. Better clarity मिलेगी आपको किस तरह से चीज़ें हो रही हैं. Okay, so starting with this, that is 2 raised to the power 0 and 2 raised to the power 1. For 3 it is 3 raised to the power 0, 3 raised to the power 1, 5 raised to the power 0 and 5 raised to the power 1. So these are the 5. So you can just add these things, like because you need to find the sum of factors, you can just add these numbers and essentially you can multiply those numbers. So here it will be 2 raised to the power 0, that is any number raised to the power 0 is 1. So 1 plus 2, that is 3. Here also 3 raised to the power 0 is 1 and 3 raised to the power 1 is 3. So 3 plus 1 will be 4. And here also 5 raised to the power 0 is 1, 5 raised to the power 1 is 5. So 5 plus 1 will be 6. So what you will be getting here is that 6 into 4, 24, 24 into 3, that is 72. Okay. So you can check this with the help of example also. 30 plus 15, it is 45. 45 plus 10 is 55. 55 plus 6, 61. 66, 69, 71, 72. Okay. So you can check it, because of which I have taken this example, so that आपको better clear हो किस तरह से इस formula तक हम पहुँचे. Okay. So because I explained you this formula in the last slide, so I think it must be pretty much clear कि हमने किस तरह से sum of factors भी with the help of this example calculate कर लिया. Okay. So you can apply it for any other number also. कोई अगर आप larger number लोगे, so you can apply the same concept and you will be able to calculate sum of factors. So you can apply the same rule for, let's say I can remove this. So you can apply the same rule for sum of even factors, sum of odd factors, like I told you in the last slide. So sum of even factors, if you want to calculate, so it is 2 raised to the power 0 plus 2 raised to the power 1. That was just writing it. Okay, so because we need to calculate the sum of even factors, so we won't calculate 2 raised to the power 0. Like I told you, अगर हमने इसको calculate कर लिया, so हमारे पास कोई even number बचेगा नहीं फिर आगे, right? मतलब कुछ odd value भी calculate हो जाएंगी. Okay, so just neglecting 2 raised to the power 0. So essentially what we will get is 2 raised to the power 1 from here. Okay, that is 2 multiplied by, again the two of the remaining values will be same. That is 3 raised to the power 1 is 3. 3 raised to the power 0 is of course 1. So 3 plus 1, that is 4. And 5 plus 1, that is 6. That is 48. That was about even factors. Now using the same logic, we can calculate sum of odd factors also. So what we can do here is that, again I am writing just for the better understanding. So because we need to calculate the sum of odd factors, so we will just not look at the 2 power, right? Because 2 will give us even numbers. So we'll just ignore this. You can just cancel this and write the remaining values to get the sum of odd factors, like we did for the in the last slide, like we did. I think because like in the odd factors also, we just ignored this term that has 2 raised to the power some power. So we just ignored that term and we wrote the remaining terms. So we can do the same thing here also. We just need to neglect the term which has some power of 2, and we need to write the remaining terms. Again, it will come as 4 into 6, that is 24. Again, you can see that I think we calculated in the last slide the sum of factors was 72, right? So 48 plus 24 will be 72. So sum of odd factors and sum of even factors, if we add those sums, we will get sum of total factors. That is pretty obvious, I guess. So I think with the help of this logic, you will be able to understand how to calculate sum of factors, right? Sum of factors, sum of odd factors, sum of even factors should be clear. Now let's try to understand how to calculate product of factors. Okay, again taking the same example, that is n is equal to 30, 30. Okay, so again 1, 2, 3, 5, 6, it is 10, 15 and 30. Even though I can tell you the direct formula, but again थोड़ा सा कैसे formula तक आते हैं, clarity आनी चाहिए, right? Okay, so here what you can notice is that the product of 1 and 30. What will be the product of 1 and 30? Of course 30. Okay. So again, because we want to calculate the product of factors, so we will multiply all those numbers. Now if we want to, if we take another pair, that is 2 multiplied by 15, that will again give us 30. 2 into 15 is 30. Okay. So now we will do the remaining values, that 3 multiplied by 10 will also give us 30. Same for 5 and 6 will also give us 30. So I guess you will be able to identify till now. What we are doing is that we are forming the pairs, taking one number from the initial, let's say total जो factors हैं, starting से आपने एक नंबर लिया, लास्ट से एक नंबर लिया, so जो उनका प्रोडक्ट है वो एक्चुअल नंबर के बराबर होगा. अब स्टार्टिंग से लेट्स से आप यू आर टेकिंग सेकंड नंबर एंड फ्रॉम द लास्ट आल्सो यू आर टेकिंग सेकंड नंबर, सो उनका जो प्रोडक्ट होगा वो नंबर के इक्वल होगा. सो बाय यूजिंग दिस लॉजिक आई थिंक इट मस्ट बी वेरी मच क्लियर टू यू कि हम किस तरह से इसके लिए फॉर्मूला भी डिराइव कर सकते हैं. सो फॉर्मूला क्या हो जाएगा इसका फिर? सो प्रोडक्ट ऑफ फैक्टर्स विल बी नंबर raised to the power number of factors divided by 2. बिकॉज जब हम दो नंबर से एक पेयर बना रहे हैं तो हमें एक्चुअली नंबर मिल रहा है वो, राइट. सो जो टोटल नंबर ऑफ फैक्टर्स होंगे उसको 2 से डिवाइड करेंगे, उतनी बार वी आर मल्टीप्लाइंग द नंबर सो दैट वी आर गेटिंग टू द प्रोडक्ट ऑफ नंबर्स. हियर ऑल्सो वी कैन सी दैट द वैल्यू कम्स आउट टू बी 30 raised to the power 4. I'll write it here. 30 raised to the power, because 30 is multiplied 4 times, so this will come out to be 30 raised to the power 4. Okay, so you know that factors of this number are 8 factors. So essentially we are multiplying this number by 4 times, which is a number raised to the power number of factors, that is 8. So 8 divided by 2 will give us 4, which is this. So instead of just learning this formula, I think this should be clear by this logic also. Okay, so I thought to explain you the logic behind the formula, and I hope this must also be pretty much clear. If you have any doubt, you can just put it in the chat box. So I think Udit, you have written okay sir, but you have taken number 210 also. So I'll take your example also. Don't worry, I'll take your example also. Just I think there's one more. Okay, let's complete the divisibility rule also. Then I'll take your example 210. I'll explain it to you. Okay. Yes, so I think we should continue now because there were no further doubts. Yeah, so this is about divisibility rule. So I think this must be a pretty easy thing to identify, that any number, if we want to check about the divisibility by 2, when we just need to check the last digit. For example, if I have any number, let's say 2, 5, 7, 3, 2. So just to check whether this number is divisible by 2 or not, we need to check just the last digit. So if the last digit is divisible by 2, then this complete number will be divisible by 2. Okay, so this last number can be, let's say, if I take another example, it is 5, 1, 3, 7, 2, 1, 4. So because 4 is divisible by 2, so this number will also be divisible by 2. Complete number will be divisible by 2. So this number can be 0 also, 2 also, 4, 6 or 8, because all these numbers are divisible by 2. So essentially if any number is ending in 0, 2, 4, 6 or 8, so it will be divisible by 2. I think this was pretty much simple calculation. Same way we can find the divisibility rule for 8 as well as 4 and 16 also. See, for 4 we need to check the last 2 digits. Again, taking the same example or maybe some different value. For example, if I take 5, 1, 3, maybe 4, 3, 2. Okay, so if I want to check whether this number is divisible by 4, so instead of completely dividing this number by 4, what I can do is just check the last 2 digits. If the last 2 digits are divisible by 4, then this complete number will be divisible by 4. Okay, so because 32 is divisible by 4, 4 into 8 is 32, so this complete number will be divisible by 4. Okay, taking the same example for divisibility of 8 also, if the last 3 digits, okay, it is 5, 1, I think I took this number only, maybe. So if the last 3 digits are divisible by 8, then this complete number will be divisible by 8. Okay, we just need to check the last 3 digits. So we can just check, okay, we can check it by dividing it by 8. 8 into 432, 8 into 5. Okay, 8 into 5 is 40. So that is 3. 32, 8 into 4 is 32. Okay, so that is because the last 3 digits are divisible by 8. So this complete number will be divisible by 8. So it doesn't matter how long the number is. Let's say I take 3, 5, 9, 2, 1 and so on. We just need to check the last 3 digits. If the last 3 digits are divisible by 8, then the complete number will be divisible by 8. Same I think you can do for the 16 also. We just need to check the last 4 digits. Okay. For the same number, you just need to check the last 4 digits. If 1, 4, 3, 2, if this number is divisible by 16, then the entire number will be divisible by 16. Okay. Now let's come to divisibility by 6. Okay, if any number is divisible by both 2 and 3, then the entire number will be divisible by 6. So even though I have not told you about the divisibility of 3, we will be learning in the next slide. But okay, let's try to understand. So any number, if we want to check the divisibility by 3, we can just add the digits of these numbers. If the sum is divisible by 3, then the entire number will be divisible by 3. Try to understand it with the help of example. Let's say we have a number 5, 1, 4, 2, 3 or maybe 8. This is a number that I have taken. So to check the divisibility by 3, we should just add these numbers. If the sum of the digits is divisible by 3, then the entire number will be divisible by 3. So 5 plus 1 is 6, 6 plus 4 is 10, 10 plus 2 is 12, 12 plus 3, 15, 15 plus 8, 23. So because 23 is not divisible by 3, then this entire number won't be divisible by 3. Let's take one example in which the number is divisible by 3. Let's say 4, 7, 8, 2. Okay. Yes, so I have taken a number 4782. So 4 plus 7 is 11, 11 plus 8 is 19, 19 plus 2 is 21. So 21 is divisible by 3, 3 into 7 is 21. And also the last digit is 2. We know that if any number is ending in 0, 2, 4, 6, 8, so those numbers are divisible by 2. So essentially this number is divisible by 2 as well as 3. So this number will also be divisible by 6. Okay. If any number is divisible by 2 as well as 3, then the entire number will be divisible by 6 also. Okay, I think this should be clear. If you have any doubt, you can ask. So I already told you about the divisibility of 3. That is, if the sum of digits is divisible by 3, then the entire number will be divisible by 3. And also we can see for the divisibility of 9 also. If the sum of digits is divisible by 9, then the entire number will be divisible by 9. Same like we did in the case of 3. If I take the same example, that is 4782. Okay, if the number is 4782, because the number sum of digits is 21, we calculated in the last slide. So because 21 is not divisible by 9, then this entire number will not be divisible by 9. But if I had one more value, let's say I had 6 also, so 21 plus 6 will be 27. Now 27 is divisible by 9, so this number will be also divisible by 9. We just need to check the sum of digits. If it is divisible by 9, then it will be the complete number will be divisible by 9. The divisibility of 5, I guess it is the most easiest one among the all divisibility rules. If any number is ending in 0 or 5, then that number will be divisible by 5. If the number is, let's say, 505, of course if it is ending in 5, then it is divisible by 5. You can write it as 5 into 101. Or let's say if I take a number that is ending in 0 and maybe 720, maybe I take a number 720. So because this number is ending in 0, so this number will also be divisible by 5. It is the easiest of all. Okay, now let's look about divisibility by 11. So for divisibility of 11, you need to check the sum of odd digits minus sum of even digits. It should be either 0 or divisible by 11. I think it should be divisible. It should be divisible by either 0 or 11. So let's take an example. Because we know the square of 11 is 121. Let's try to apply it on that particular value. If I take the value of x to be, let's say, 121, and I need to check whether this number is divisible by 11 or not. So we just need to see the sum of odd digits. That is, this is the odd place, right? That is the first place that is odd. So this and this sum of first and third, that is 1 plus 1 plus 1 minus sum of even digits, that is 2. So that is 2 minus 2, essentially it is 0. So if so now we got the value as 0. So if sum of odd digits minus sum of even digits is coming to be 0 or 11, then this entire number will be divisible by 11. So this will be applicable for larger numbers, of course. So let's try to take a larger number. Let's say I took a number 513429 okay. So I took a larger number. So let's try to apply this divisibility by 11, sum of odd digits minus sum of even digits. So the odd digits are 5. Let's start from here. 7 plus 2 plus 3 plus 5. 7 plus 2 plus 3 plus 5 minus 9 plus 4 plus 1. Okay. So what we will get is 7 plus 3, 10, 15 and 2, 17. So here what we will get is 9 plus 4 is 13, 13 plus 1 is 14. So the number that we got is neither 0 nor 11. So this number is essentially not divisible by 11. So I think you can just apply this rule if you want to see whether any number is divisible by 11 or not. You can just add the digits on the odd place. You can subtract the sum. You can add the digits on the odd place and you can subtract the sum of even digits. If it is 0 or 11 or maybe divisible by 11, it is not that it should always come as 11. If let's say this comes out to be, let's say 0, 11 or 22, 33. Okay, because 11, 22, 33 are divisible by 11. So if we are getting any number which are divisible by 11, so that entire number will be divisible by 11. Okay, I think this should also be pretty much clear to you. Let's look if you have any doubts. Okay, that is fine. Moving ahead. Okay, this is about HCF and LCM. So HCF, as its name suggests, highest common factor, and LCM is least common multiple. So for HCF, it is greatest number that divides two or more numbers. Of course, we have already taken an example, that is 18 and 24. Let's try to apply on this particular example only. If we want to calculate HCF of 18 and 24, so first we will have to find the prime factorization of these numbers. So we can represent 18 as 18 you can write is 2 into 9, that is 2 raised to the power 1, and for 9 you can write as 3 ka square, right? 3 square is 9. For 24, the second number is 24, so we can write 24 as 3 into 8. So it will be 3 into 8. 8 is 2 raised to the power 3. So I think I should write 2 before 3. So this is 2 raised to the power 3 into 3. So this is the prime factorization for 18 as well as 24. So now we need to find highest common factor. So what is common in those two? For the value of for the term 2, for the prime number 2, what is common in the two values? That is 2 raised to the power 1. Because let's say if I take 2 raised to the power 2, then 2 raised to the power comes in the second value, but it doesn't come in the first value. It has only 2 raised to the power 1. So we can't take 2 raised to the power 2. So the highest that we can take is 2 raised to the power 1, which is common in both the values. Okay. So it will come out to be as 2 raised to the power 1, which is common in both the values. Okay. For the second also, you can see that it has 3 raised to the power 1, and 24 has 3 raised to the power 1, and 18 has 3 raised to the power 2. So we need the common between two. Common is 3 raised to the power 1. So it will come out as 3 raised to the power 1. So multiplying 2 and 3 will give us 6. Okay, so this is the highest common factor, that is HCF of these two numbers. So that we got here. One more thing is that because this is the highest common factor, because this number is essentially dividing both of these numbers, so I can represent 18 as well as 24 in the form of 6k, where k is any constant. Okay, so what I'm trying to tell here is that if I have a number 18 as well as 24, so I can write 18 as 6 into 3. I can write 24 as 6 into 4. So this is the HCF. So I can represent first number as in the form of 6k1, where k1 is 3. Here I can write it as 6k2, where k2 is 4. Okay, so I can represent the numbers in the form of its HCF, because the whatever was common, I took it in the HCF, and the remaining two numbers, that are k1 and k2, will be co-prime. I already told you about the co-prime numbers, right? So k1 and k2 will be co-prime, because if anything was left common in the two numbers, then we could have included it in the HCF itself. But because there was nothing common left, so these two numbers, that are k1 and k2, will be co-prime to each other. Okay, so we can represent the numbers in the form of HCF also. Now looking at the LCM of 18 and 24. Okay, so again 18 and 24. So we can write 18 as 2 into 3 ka square, and we can write 24 as 3 into 8. 3 into 8. So 8 is 2 raised to the power 3 and 3. Okay, so now we just need to see the highest power of every prime number. So here the highest power of 2 is 3. Here we have the power of 3 as 1. Here the highest power of 3 is 2. So we are taking the more power, right? So here it has the power of 3 as 2. So essentially we will take 3 raised to the power 2. To calculate the LCM, we need the highest power of every prime number between the two numbers, or maybe three numbers, whatever we want to calculate. So what we will get here is that 8 2 raised to the power 3 is 8, and 3 raised to the power 2 is 9. So it will give us as 72, which is this. And also one more important fact is that the product of numbers is always equal to product of LCM as well as HCF. That is, we know the HCF is 6 and LCM is 24. Sorry, LCM is 72. So this product will be equal to product of the numbers. The numbers are 18 as well as 24. So this will be equal to 18 into 24. This is also an important result here that we need to keep in mind. Okay, this is what this particular term is here written, that is product of numbers will be equal to HCF into LCM. I think this is also clear. If you have any doubts, you can just put it in the chat box. Yes, Udit, there is, I think there is one rule to calculate the divisibility by 7, but that is kind of too complicated. So instead of learning that the divisibility rule, it is better to do the manual calculation. Even though you will be able to find some divisibility rule for 7, but what will be the better approach? Just do the manual approach, because जो भी उसकी आपको divisibility rule मिलेगा वो बहुत complicated हो जाएगा. उसको करने से अच्छा है कि आप normal करोगे तो आप जल्दी कर पाओगे. Because of the same reason मैंने उसका divisibility rule include भी नहीं किया. Okay. I think that should also be clear. Okay, moving ahead. Okay, so let's start with some questions. This is the first question. You need to find the number of odd factors for 2700. So you can try this question. Okay, try this out. I think timer is visible. You have 1 minute of time for solving this question. Okay, let's solve this question. Okay, so we need to find the odd number of factors for 2700. So first, let's try to do the prime factorization. So 2700 can be written as 27 into 100. 27 is basically cube of 3, that is 3 raised to power 3. 100 is 25 into 4, that is for 4 we can write 2 raised to power 2, and for 25 you can write 5 raised to power 2. Even though you can do it with a manual calculation also, but I would not recommend to do the entire number as the manual calculation, like I told you in the initial slide, that if you will be doing it like this way, 2700 divided by let's say 2 and so on, it will be too lengthy, right? So what you can do is that just try to remove all those zeros. अगर किसी नंबर में बहुत सारे zeros आ रहे हैं तो आप उसको remove कर दो, उसके अलावा जो नंबर बच रहा है उसका prime factorization you can do it. Okay, let's say if you are not pretty much comfortable how to do of 100, so you can just do it of 100, so that you can write it as 50 or maybe then 2 raised to the power 25 and so on. But you know that 10 is equal to 2 into 5, right? You know 10 is equal to 2 into 5, that is 2 raised to the power 1 and 5 raised to the power 1. So what will 100 be? 2 raised to the power 2 and 5 raised to the power 2 and so on. So just to ease the calculation, you can just remember this, that 10 is equal to 2 into 5, 100 is equal to 2 raised to the power 2 and 5 raised to the power 2 and so on. You won't be doing the complete calculation, right? 2700, then you will be dividing by 2 and so on. With practice, you will be able to do this calculation a lot faster. So it will be 2 raised to power 2, 3 raised to power 3 and 5 raised to power 2. So what I told you for odd number of factors, you can just ignore the even number. Okay, so what will be the odd number of factors? It will be 3 plus 1 multiplied by 2 plus 1. That is 4 into 3, 12. So this will be the odd number of factors for 2700. So let's try to do for even number of factors also. If I had to calculate the even number of factors, what I would have done? I would have not included 2 raised to the power 0. That is, I would have not added 1 to the first term. So for even factors, what I would have done is, I would have not added 1 to this number. So it will be 2 into 4 into 3. That is 4 into 3 is 12 into 2. That is 24. Okay, I think I'm missing out something. No, that's fine. Okay, so for even number of factors, you will just need not to add 1 to the term which has 2 raised to some power. Okay, so by using this you can calculate the even number of factors also. 3 into 4, 12 into 36. Okay, so all the factors will be, total factors will be 3 into 4, that is 12, 12 into 3, that is 36. So sum of the factors will come out to be 36. Okay, so I think this should be pretty much clear. This was an easy level question. If you have any doubts, you can just ask. Yes, Udit, the answer is correct. The answer is 12 for this question. Try the second question also. Okay, try this question. This is a good question. This is based on HCF and LCM concept. Okay, try this. You have 2 minutes for this question. Okay, I think the time is up. We should start solving this question now. Okay. So in this question we are given that, the product of two numbers is 6498 and the HCF is 19. So how many pairs of such numbers exist? So like I told you, the product of two numbers is equal to product of HCF and LCM, right? And also we can represent the numbers in the form of its HCF also. Like if the HCF is 19, so we can represent the numbers in the form of HCF with some common constant. For example, let's say the two numbers be 19k, k1 I can take. Okay, the second number I can take is 19k2, where k1 and k2 are co-prime numbers. So we can represent the numbers in the form of its HCF. So we are told the product of the numbers is 6498. So just try to apply this because the numbers are 19k1 and 19k2. So 19k1 multiplied by 19k2. Okay. So it will be equal to 6498. So just doing the basic calculation now, it will cancel out from 19. It will come out as 19 into 3, that is 57. Then 4 and 3, 7, 79. So 19 into 4, that is 76. So 3 is left, 38 is 19 into 2. I'm just doing the basic calculation. So it will cancel out with the help of 19 also, I guess. So 19 into 1, 19. So 15 is left, 152. So 19 into 8 is 152. Okay. So k1 multiplied by k2 will be 18. So now we know that k1 and k2 are integers and also they are co-prime to each other. So what all possibilities we have? We can write 18 as 1 into 18. We can write it as 2 into 9. We can write as 3 into 6. And after this, the numbers will start repeating, like 6 into 3 and 9 into 2, 18 into 1. Okay, so these are the only three possibilities that we have. So now, but this case is not possible because 3 and 6 have a common factor between them. Like 3 and 6, 3 and 6 both are divisible by 3, right? 6 is 3 into 2, 3 is 3 into 1. So these two numbers are not co-prime because both our numbers are divisible by 3. So this case is not possible. So the only two possible cases that we have are 18 into 1 and 9 into 2. So what will be the numbers be? 19, by taking the first case, it will be 19, and the second number will be 19 into 18. Some number will come, okay? It will be 19 into 18. So this is the one possibility of numbers that will satisfy this equation, this condition. Second will be 2 and 9. So it will come out to be 19 into 2, that is 38, and 19 into 9, that is 171. But these are the two possible pairs. So two possible pairs, that is option number C. Even though we need not to calculate the value of the terms, I just calculated because I got the value. So only one case was not possible, that is 3 into 6, because these numbers should be co-prime, but they have a common multiple between them, that is 3. So only two possible cases are there, 1 into 18 and 2 into 9. I think this should also be clear. If this is clear, we can move ahead to the next question. Yes. Yeah, it feels it is pretty much clear to you. Moving ahead to the next question, it is question number 3. Try this question. I think this is also a good question, pretty conceptual question. I'm giving 1.5 minutes for this question. Try this. Okay, the time is about to end. Let's try this question. Okay. So let's try this. Geeta thinks of a number x. She notices that 2x has odd number of factors. Which of the following statements about x is definitely true? So this is an important statement here, that 2x has odd number of factors. So only the perfect square numbers can have odd number of factors. Let's try to understand that with the help of an example. Let's say you have a number 36. You have a number 36. So how you can write it in the form of prime factorization? It will be 6 square, yes. So 4 into 9. So that is 2 square into 3 square. So essentially the number of factors will be 3 into 3, that is 9. So here you can see the number of factors are odd. I can take one more example. Let's say I took a small number 25. Okay, so for 25 the number is 5 raised to the power 2. So essentially the number of factors will be 2 plus 1, that is 3. If I take any other number, maybe let's say 20, I take the number 20. Then for the number 20, it will be 4 into 5. So 2 raised to the power 2 into 5, that is 3, because 2 plus 1 will be 3. here the power of 5 is 1, so 1 plus 1 will be 2. So the number of factors will be 6. So you will notice that for all the numbers apart from perfect square numbers, the number of factors will be even. And also you can understand why we are getting this. I think I need to explain this also so that it is better, you get better clarity about it. Okay, let's take the example of 36. So for 36, the number of factors will be 1, 2, 3, 4, then 6, it is resolved by 9 also, then 12, then 18, then 36. Okay, and the other number that I took was 20. Okay, so for 20 the number of factors will be, okay, so the number of factors for 20 will be 1, 2, 4, 5, 10 and 20. So what you can notice here, like I told you, for the number of factors, when we were to calculate the product of factors, so here you can see that 1 multiplied by 20 will give us the number, right? Same, you will see 2 multiplied by 10 will give us the number, 4 multiplied by 5 will give us the number. So we have even number of factors because we are able to form the pairs. But here notice that 1 multiplied by 36 will give us 36. 2 multiplied by 18 will also give us 36. Same for 3 and 12. Same for 9 and 4 and 9. But we are not able to find the pair for 6, right? Because of which, apart from the pairs that we are getting, one number will be left. So these will be pairs. So this will lie in the even number of terms, for example, because these are forming pairs. So 2 के मल्टीपल में होगा, राइट? कोई भी नंबर अगर ये पेयर बना रहा है तो 2 के मल्टीपल में होगा वो, राइट? सो इसके साथ वी आर left with one more number, so it will be 2k plus 1, that is odd number of factors. So because of this reason, any number which is a perfect square number, it will always have odd number of factors. And apart from that, for all the numbers, we will be able to see that the number of factors will be always even. So this was the concept behind this question. Okay, so using this concept, we are given that Geeta thinks of a number x. She notices that 2x has odd number of factors. So if 2x has odd number of factors, that means the number 2x is perfect square. Okay, so 2x is definitely a perfect square. At the same time, you can see that if the number is perfect square, then all the 4 into 9, yes. If the number is perfect square, then all the powers of the prime factors will be even, because the number is perfect square. So आपके पास जो भी नंबर है उसकी इवन पावर होगी, so that वो पेयर बना पाए, right? So noticing this, that every number which is a perfect square, the power should be even. So here, if this number is a perfect square, that is 2x. So if she is thinking about a number and we are asked to find which of the following statements about x is definitely true. So we are asked to calculate about x. So for x, we need to calculate, and 2x is a perfect square number. So now we are removing 2 from here. So we are left with x. So 2x was a perfect square number. So by multiplying x with 2, we are getting a perfect square number that the value of the power of 2 was getting even when it was getting multiplied by 2. So now because we have removed 2 from there, so the power of x, the power of 2 in the number x will not be even. So the power of x will be odd. Either it will be odd or there will be no, it will be one power, because let's say the x had no value, no term, no prime factor as 2. So essentially when we are multiplying it by 2, so now, okay, I think I've just confused you. Okay, so if we have 2x, so it is a perfect square number, right? So if we are removing the 2 from that number, so the power of x will be odd, because in every perfect square number, the power will be even. So here the power should be even when we are multiplying it by 2. So when we have removed the 2, so the power of 2 in that particular number will be odd. So if the power of any number is odd, so that particular number cannot be the perfect square number. So we can say for surety then the x can never be a perfect square number, because the power of x, the power of 2 in the number x will be odd. Okay, I think I was able to explain this question also. If you have any doubts, you can just put it in the chat box. Okay, you can ask whatever doubt you have. This can be solved with the help of just this logic. I think there are no doubts, so that we can continue to the next question. Okay, so try this question. I think this is an easy question. The smallest natural number which has 8 factors. The smallest natural number with exactly 8 factors. Try this. I think you will be able to do it. It would be better if I had not included options for this question, because you can just try to check with the options, but anyways, try this question. Okay, the time is up. Let's try to solve this question. Okay, let's try to solve this. Yeah, so the smallest natural number with exactly 8 factors. So I think by using the options also you can solve. You can start with 24, because you are asked to find the smallest natural number. So you can start with 24, and then you can, let's say, start if let's say 24 does not satisfy, you can check with 32 and then 54 and 64 and so on you can do. So if you are following that approach, let's say starting with 24. So for 24 you can write it as 8 into 3. Okay, so 8 is basically 2 raised to the power 3. So 2 raised to the power 3, that is 8 into 3. So the number of factors will be 3 plus 1, that is 4, and 1 plus 1 will be 2. So yeah, we have got the number of factors as 8. So we can mark this as option D. But if we did not have the options, how then we could have done this question? Let's try to understand that also. So how do we calculate the number of factors? We just first try to break it in the we first try to do prime factorization, right? If the number is, let's say, n, so what we do is, let's say the prime factorization for the number is a into b into c, and the power of a is, let's say, p, the power of b is q, the power of c is r. So this is the prime factorization that we are doing. Let's say if because we are wanting the because we want the total factors to be 8. So if the number had only one prime factor, so let's say the number was of the form a raised to the power p. So to get the total number of factors as 8, we should have the value of p as 7, because if the value of p is 7, then only we can say that the total number of factors will be 7 plus 1, that is 8. But in this case, the smallest value that we can get is 2 raised to the power 7, that is somewhat larger than 100. It will be 2 raised to the power 32, 64, 128. Okay, yes. So 2 raised to the power 7 will be 128. We are getting a larger number, right? More than 100. So this is the first case that we can do. Apart from this, what we can do if the number of factors are 2, number of prime factors are 2. So if the number is of the form a raised to the power p as well as b raised to the power q. So if it is of this form, so what we can do is we can write it as 4 into 2, because 4 into 2 is 8, we need 8 factors. So here the power of a should be 3 and the power of b should be 1. So here you can ask why we are taking the power of a as 3. See, because the value of a is smaller, because a is a smaller prime number, that is if we are taking the value of a as 2, So 2 raised to the power 3 multiplied by 3 raised to the power 1 in this case will give us a smaller value as compared to if we are, let's say, we are taking a raised to the power 1 and b raised to the power 3. So here also we can do 2 into 4, that is 8. But here, because the smaller prime number is a, that is 2. So 2 raised to the power 1 multiplied by 3 raised to the power 3 will give us a larger number, because 2 multiplied by 27 will be 54. But here it is 2 raised to the power 3 multiplied by 3 raised to the power 1, that is a smaller number. So because of that reason we are giving a larger power to smaller number so that the overall value is smaller. Okay. So by using this logic, what we can say is that 2 raised to the power 3 multiplied by 3 raised to the power 1. So it will be 4 into 2. Again, of course, we got the value as 8. That was the obvious case because we did the same thing. So here the total number of factors will be 8. So what will be the value of the smallest number we need to find? Okay. So we will be giving the value prime number, the power 3 to the smallest prime number, that is 2. So it will be 2 raised to the power 3 multiplied by 3 raised to the power 1, that is 8 into 3, that is 24. So the value that we are getting by taking two prime factors will be 2 raised to the power 3 multiplied by 3 raised to the power 1, that is 8 into 3, that is 24. So this is one case. This was one case. We have one more case possible. What we can write is in the form of 3 numbers, because we can write 8 as 2 multiplied by 2 multiplied by 2. So we can write 8 in the form of 3 prime factors, so we will have to consider this case also. So here what we need to do is that 2 raised to the power 1 multiplied by 3, the prime factorization, say n is 3 raised to the power 1 multiplied by 5 raised to the power 1. Of course, we will be starting from the smaller prime number, that is 2, then 3, then 5, so that overall answer is smaller. We need smallest natural number, right? So because of which we are using the smallest prime numbers. So here what we will get is, of course, the number of factors will be 8, that is 2 into 2 into 2. So it will be 2 into 3, that is 6, 6 into 5 is 30. So since this number is greater than this number, so essentially the answer will be 24. So I just tried to explain how to solve these questions, because the options were available, so you could have just used the options. But in case the options are not available, then you should use this approach. Okay, if there is only one prime factor, if there are two prime factors, if this case is possible when there are 3 prime factors, then also you will have to check that case also. And likewise, you will compare which is the smallest value, and you will be able to mark the answer. It is 24, right? Yes, you'll be able to mark the answer. I think this should also be pretty much clear to you. If you have any doubts, you can just ask in the chat box. I hope I was able to explain. Yes, Nobita. And the syllabus, you can just check our channel. All the sessions are there. The syllabus we are trying to cover, even though we don't have the clarity about what all topics will be covered, because nothing is clearly mentioned on the website. But like I told in the initial slide of this session that एक वेबिनार कंडक्ट कर रहे हैं वो लोग, सो उसमें हमें थोड़ा बेटर क्लैरिटी मिलेगी कि किस तरह से वो सिलेबस का पैटर्न रहेगा, एग्जाम पैटर्न क्या रहेगा. सो उसके बेसिस पे वी कैन डू द फर्दर सेशंस ऑल्सो. So yes, by 30th of November, we will try to cover all the major topics. Okay, so you can just subscribe to the channel. You can visit the video section or the live section. There you will be able to find all the videos. The sessions are being conducted. Okay. Think we can move ahead. Moving ahead to the next question, that is question number 5. This is based on the divisibility. Try this question. Okay, try this. I've given 90 seconds for this question. Try this question based on the divisibility rule. Okay. Okay, the timer is up. Let's try to solve this question. I think you must have tried solving this. Yes, the webinar is on. I think I included it. 1 second. I included it in the initial slides. It is on 16th of November. It is on Sunday. The timing is from 3 p.m. to 4:30 p.m. And for the registration also, there is one short video on this particular channel. You can just watch that short video so that you are able to get how. So by looking at that particular video, you will be able to realize कि किस तरह से उस वेबिनार के लिए आपको रजिस्टर करना है. Okay. Which course you are talking about, Soumik? Can you please clarify? Okay, so meanwhile, I think we should start with this question. Okay, so a number 379A1067B53. Okay, so this is divisible by 3, and if both A and B are single digit whole numbers, then what is the largest possible value of A plus B? Okay, so like I told you, for the divisibility of 3, we need to just check the summation of numbers, summation of digits. If it is divisible by 3, then the whole number will be divisible by 3. So I think this should be an easy question. Let's try to solve this. So here the number is 379 A106 A106 7B53 7B5 and 3. So this is the number. So we just need to add the digits, and if it is divisible by 3, then the number will be divisible by 3. So we can just eliminate the numbers that are already divisible by 3, that are these numbers. So what we are left with is 7 plus A plus 1 plus 0 plus 7 plus B plus 5. So this will give us 7 plus 1 8, 8 plus 7 15, 15 plus 5 20. I think I've done the calculation correctly. 106 7B53. Okay, so 7 plus 1 8, 8 plus 7 15, 15 plus 5 is 20. So this is 20 plus A plus B. So this is essentially equal to, so this should be equal to a multiple of 3. So the value of A plus B will be either 1 or 4 or 7 and so on. Okay, so because we want this to be multiple of 3 and smallest multiple of 3, that is greater than 20, because these two numbers are whole numbers. We can't take negative numbers, of course, we can't take negative digits. So adding something to 20 will give us a larger value from 20. So essentially we need the numbers which are greater than 20 and are divisible by 3. So the smallest number will be 21, right? So for this complete term to be equal to 21, we will need the value of A plus B to be equal to 1. Okay, after that, if we are taking, let's say, equal to 1, then this will become 21. If we will take it as 4, A plus B value, if we take the value of A plus B as 4, then the complete term will become 20 plus 4, that is 24. That is also divisible by 3. So likewise, we can see all the values. One more thing here is that because A and B are single digit whole numbers, so the largest value that A can take is 9. The largest value that B can take also is 9. So the summation of A and B should be less than equal to 18, right? Because the largest value that A can take, because it is a whole number and a unit digit, so the largest number that A can take is 9, and the value that B can take is also 9. So their summation cannot exceed 18. So let's say we consider the sum to be 18. So what we will get here is that 20 plus 18, that will come as 38. But 38 is not divisible by 3, and we cannot go further because the largest value that A and B can take is 18. So we need to check for some smaller values. So the values that are smaller than 38 and are divisible by 3 will be 36, right? Number is smaller than 38 and it should be divisible by 3 will be 36. So for this complete term to be equal to, to make this complete term equal to 36, we will have to take the value of A plus B as 16. So this is the largest value that we can take for a plus b, so that it is the complete term is divisible by 3. So for this question, the answer will be option number D, that is 16. I think this should also be pretty much clear. If you have any doubts, you can ask. See, like I told you, na, Nopita, you can just check the short video. This is on this particular channel only. I think I can show you. So this is the IIMB channel. I think this should be visible. You can just visit the channel. So here you can see the short video and the complete details are shared in this. Okay. Okay, I'll try to put the link of that webinar in the comment section after this session. You can just put your query that you need the link of that webinar in the comment section of this video, and I'll try to help you out. Okay. Okay. Let's try to move ahead to question number 6. If we have, yes, we have. So how many 7-digit numbers of the form this exist such that they are divisible by 9? Of course, A and B are single-digit whole numbers. Try this also. Try this question. Okay, try this. Okay, so the time is up. Let's try to solve this question. How many 7-digit numbers of the form this exist such that they are divisible by 9? So like I told you, for the divisibility of 9, you just need to add the digits. So if the digits, sum of digits is divisible by 9, then the entire number will be divisible by 9. So we will be applying that approach here. So we have a 7, 1, 2, 4, 3, B. So we need to check whether this number is divisible by 9 or not. So 7 plus 2 is already 9. So 4 plus 3, that is 7 plus 1, 8. So 8 plus A plus B. So this should be divisible by 9. Okay. So this can be 9 or maybe 18, 27 and so on. So the value of A plus B can be, to make it 9, the value of A plus B should be 1, and to make it 18, the value of A plus B should be 10. And we can't take it further because for 27, the value of A plus B will be equal to 19. And like I told you in the last slide, because A and B are single digit whole numbers, so the maximum value of A plus B can be 18. So it can't exceed 18, and for 27, it will be equal to 19. So there are only two possible cases. Let's try to see what all values we can have for A and B. So for a plus b should be equal to 1 we have. So we can take a as 1 and b as 0 because these are whole numbers, right? So we can take a as 0 and b as 1. Okay. So but we are given that the number, it is a 7-digit number which is starting from a. So any number cannot start with 0. So the value of a cannot be equal to 0. Otherwise, we could have considered this case also. If the a would have been somewhere in between or maybe not in the first position, then we could have considered the second case also. But because it is a 7-digit number, so we can't start any number with 0. So this is the only possible case when we have a plus b is equal to 1. Looking at the second condition, a plus b should be equal to 10. So again, a should not be equal to 0. So value of a can be 1, value of b can be 9, value of a can be 2, value of b can be 8, and so on, 3 plus 7, and we can write the value of a as 9, value of b can be 1. So from 1 to 9, a can take all the values for the second case. So total it will be from 1 to 9, total 9 cases. It will have 9 values. And here it has only one case, that a is equal to 1 and b is equal to 0. So one case is possible here and 9 cases are possible here. So total 9 plus 1, that is 10. So how many cases are possible? How many 7-digit numbers are possible? So in total there are 10. I think this should also be pretty much clear. If you have any doubts, you can put it in the chat box. If you don't have any doubts, we can move ahead. Okay, so this is the, I guess, okay, this question is on HCF and LCM. This I think should be the last question for today. Try this. I've given 2 minutes because this will take some thinking, right? Whatever you have learned today, try to apply it. थोड़ा लॉजिकल क्वेश्चन है, ट्राई टू अटेम्प्ट. Okay, so the time is about to finish. Let's try and attempt this question. Yes, the time is up. Let's try to attempt this LCM HCF question. Okay. So in this question we are given that LCM of two positive integers a and b is 20 times their HCF. If b is 36 more than a, then find the difference between LCM and HCF of the two numbers. Okay. So like I told you, if we have two numbers and we know their HCF, so we can represent those numbers in terms of its HCF. So if the HCF of two numbers is H, so we can represent the two numbers as HA and HB. We can represent the two numbers as HA and HB, where H is the LCM and A and B are two coprime numbers. So we are given that the LCM of two numbers is 20 times their HCF. So because we have let the HCF as H, so their LCM will be 20H. So these are the two numbers. Okay, so their LCM also we are given, it is 20 times their HCF. We also know that the product of numbers is equal to LCM into HCF. So we are just trying to apply that to here because the numbers are HA and HB. So HA into HB will be equal to product of the numbers is equal to HCF into LCM. LCM is 20 times of H, that is 20H. Okay, so here we can just cancel out H and this all will also get cancelled out. So again A into B will come out as 20, and we know that A and B are co-prime numbers, so it can be written as 1 into 20 or maybe 2 into 10, 4 into 5. After that the numbers will repeat, and because 2 and 10 have two common factor between them, so we won't be considering this case. Only two possible cases are there, that A and B can be 1 into 20 or 4 into 5. Also we are given one more condition, that if B is 36 more than A, then the difference between the two numbers is 36. So if we take the first case, that if we take A as 1 and if we take B as 20, so the numbers will come out to be H into 1, that is H. The second number will come out to be 20 into H, that is 20H. So the difference of the two numbers is 36 because B is 36 more than A. So it will come out to be 20H minus H, that is 19 times of H. And of course HCF has to be the integer value. So whatever value you put for H, you won't be getting 36, right? It can be 19 into 1, that is 19, 19 into 2, that is 38, and so on. So this case is also not possible because of the second condition, that B is 36 more than A. So we are left with only one condition, that is value of A and B can be 4 and 5 in any order, right? So the values of the numbers will be 4 times of A, that is 4A. Sorry, the value of A is 4, right? So it will be 4 times of H. So 4H and 5H. And of course, because we will be subtracting a smaller number from the larger number, so the values will be 5H minus 4H, that is equal to, difference is 36. So it will come out to be 36. So H will be 36. Okay, so we have got the HCF of the two numbers, that is 36, with the help of this condition, the second condition, that B is 36 more than A. So we have already got the HCF, so we can easily calculate the LCM also, because LCM is 20 times the HCF. So I think I can write it here, that LCM is equal to 20 times of HCF. HCF is 36. So this will come out to be 720. So this is the LCM and that is HCF. So what we are asked to find is, then find the difference between LCM and HCF of the two numbers. So we have already got the two values, that is 720 and 36. So we can just subtract 36 from 720 and this will come out to be 684, 69 and 20, yes. Option number D. This was a pretty good question. So I think this should also be pretty much clear. I've tried to explain this. If you have any doubts, you can put it in the chat box. I think this should be the last question. Yes, so this is the last question for the day. If you have any further queries, you can also put it in the comment section of the video. After this session also, I will be addressing the doubts that you will be posting in the chat box of comment section of the video. Okay. So if you want to discuss anything, you can put in the comment section also. So because I could not find any doubt, I think we can just move ahead because this was the last question for the day. Okay. So this is about the reminder slides. Just give me a minute. Yeah, so this is about the test that I already told you, about the free test that we are providing. You just need to visit cracku.in, IIM Bangalore's UG mock test, and you will be able to access these 5 free tests. You just need to register on our platform and you will be able to give this free test. By clicking here, you will be able to give those tests. Okay. And also I told you about the WhatsApp group also, that the link will be in the description box. You can just click on that link. You will be able to join the WhatsApp group, and we will be sharing free preparation resources as well as important updates regarding the session that we are conducting, as well as any updates if you are getting about the exam also. So you can just join that WhatsApp group, and all the updates will be shared in the WhatsApp group. The link is in the description box, so you can join it from there. I think this was it about this slide. Okay. Okay. So just want to tell you about the sessions like I told you. Because we are conducting so many sessions, today was on number system, and tomorrow on Friday the session will be on circles, then permutation combination